Okay, Assalamualaikum. Um, so this is our tutorial video for the tutorial 7 that cover the chapter 3, thermal treatment of material, a metallic material, TTT diagram. Okay. So the question for tutorial 7, question 1, is about the time temperature transformation diagram. Okay, so the question asks you to estimate the temperature at which the transformation of austenite has been occurred. So you have to estimate the value of the temperature based on the TTT diagram. Okay, so the answer of question 1A here is 730 degrees C. Okay, so based on the isothermal TTT diagram. Okay, so just slightly above the thought temperature, which is around maybe around 750 from this diagram, and the accurate answer for our tutorial is 730. So if you answer around that value, around 720 to 770, or maybe it can be considered a right answer. Okay, but if lower than thought temperature, it is wrong. So make sure it's just slightly above of the thought temperature. That's why the question asks you the estimate value, not the accurate value. Okay, so let's go to the question B. 1B. Okay, the question is, what are meant by line 0% and 100% in the TTT diagram here? Okay, so the line 0% from the TTT diagram, you see that where the transformation begins. So the answer here for the 0% is beginning of transformation. So if you just write down the transformation begins, it also correct. Okay, and then for the 100%, what is the meaning for the 100% in the TTT diagram? Okay, you can see here, this one, the green line is 100%. So 100% is where the transformation ends. So that's why the answer here show the finishing of transformation. Okay, so that's the answer for the 1B. And for the 1C, the question is, give two possible effects on the TTT diagram when we increase the amount of the carbon to the steel. So you can find the answer in the notes, because this is like the general knowledge of your understanding on the TTT diagram. So the answer is the nose will shift to the right. This one is the nose, the curve, and then it will shift to the right when you increase the amount of carbon. Okay, so where is the answer in the notes? Okay. Okay, never mind. I didn't find your notes. You can find, and I hope you have the correct answer for the 1C. that you have done by your own. Okay, so let's go to the question 2. Using the isothermal transformation diagram for an iron carbon alloy of eutectoid composition, specify the nature of the final microstructure, okay, in terms of microconstituent present and approximate percentage of a small specimen that has been subjected to the following temperature treatments. In each case, assume that the specimen begins at 760 degrees Celsius and that it has been held at this temperature long enough to have achieved a complete and homogeneous austenitic structure. Okay, so the question asks you to find the term of micro constituent present and also the percentage. Okay, so let's see the isothermal transformation. Okay, this one. So rapidly cool to 350, hold for 10 seconds, 10 to the power of 4 seconds, this one, this graph, and quench the room temperature. Okay, so quench directly to the room temperature. So you will get the 100% by night here, B. Okay. Rapidly cool to 350. Yes, around here 350 and hold at 100,000 seconds. 10,000 seconds. Okay, so around here, then this is in the region of the B here. B is the by night, so it is 100% by night. Okay, so question B is rapidly cool 250. Okay, 760. That's right. Hold for 100 seconds. So 10 to the power of 2 is 100 seconds. And then quench to room temperature. So around here, right? Hold 100 seconds. 250. 250. So it is okay, should be around here. This one is set 90%, so around here is 100%. So the answers for the B is 100% monazite. And the question C is rapidly cool to 650 degree, hold for 20 seconds, rapidly cool to 400 degrees C and hold for 1000 seconds and quench to room temperature. So the question for this one is 50% pure light, so and 50% by night. So around here, B plus B. Okay, around here. Okay, and then the answer for the D is 50% fine pure light, 25% by night, and 25% monazite. Okay, or maybe 25% fine pure light, 37.5% by night, and 37.5% monazite. Okay, so you can compare your answers with the this one with the answer scheme here. Okay, then the E reheat the specimen in part D to 700 degrees C for 20 hours and you will get 100% ferrite. Okay, and F rapidly cool to 3000 C, hold for 20 seconds and quench to room temperature in water. Okay, the other questions all quench in the room temperature, but the final questions here you have to quench the room temperature in water. Okay, reheat to 4 to 5 degrees C for 1000 seconds and slowly cool to room temperature, and then you will get 100% tempered monazite or 100% monazite. Okay, so this is the answer for the question 2. you can compare with your answers, and if you have problems, let's discuss in WhatsApp group, or you can ask the questions, your problems in our Google Classroom. Okay, so let's go to the question 3. Okay, using the time temperature transformation diagram of eutectoid composition given, sketch the time temperature path to produce the following microstructures at room temperature. Okay, so you have to sketch the time temperature path to produce the following microstructures at room temperature. So for the A, 100% by night. Okay, so this is the line for the A where you want to get the 100% by night. Okay, B 100% martensite, C 50% perlite and 50% martensite, D 25% perlite and 75% bainite, and E 100% coarse perlite, and F 50% fine perlite, 25% bainite and 35% martensite. So the answer is in this diagram. Okay, so the red line here represents for the answer of question A, and B is represented by the orange line, C the blue line, D black line, E the purple line here, and F. Okay, so this is the answer for the question 3 in your tutorial 7. Okay, let's check your answers with this answer scheme. And if you have problem, also can ask or discuss in our WhatsApp group. Okay, so I think that's all for the tutorial 7. You have to try. If you do not do the tutorial 7 yet, make sure you have to do to complete it, and by studying the chapter 3, and then you can compare with the answers that are discussed in this video. Okay, so I have mentioned many times before, there is no short way for the material science. You have to do by your own, to read, to memorize, to understand, and to do the exercise. So we have the tutorial for your exercise, and these are the answers for your tutorial 7 to help you in learning chapter 3. Okay, so that's all for this video. Good luck with the chapter 3, and in the next video I will show you the answers for the tutorial 8. Okay, so until the next video, take care of yourself. Assalamualaikum and bye bye.